Hey guys, my name is Doc Chelle. Welcome to Dr. Test Prep, and I am starting a new series called Your Questions Answered. So I am in a couple of SAT Facebook groups, and I often see kids post questions about how do I do this problem, and I'll do a mixture of math and reading in this series, so it won't just exclusively be math. And here is our first video question. Your Questions Answered, Episode 1. Let f of x equal x squared minus x plus 3 and g of x equal f of x plus 3. What is the range of g of x? So we've got two things going on. We're learning how to do like composite functions like f of g of x. And then we're testing, do we know the difference between domain and range? And I am in my room and you can see Orion hanging out behind me. There he is. Okay, so open up Desmos. You're going to go to choose assessment and College Board. If you don't do this, it might not work. I don't remember which parts work and which parts don't, but I know there have been times I was recording videos and it wasn't working in the beginning and I realized I forgot to set it on College Board. Okay, so all we need to do is literally type it in. We've got f of x equals x squared minus x plus 3. Desmos is smart enough to interpret the next piece. So our first graph is red. Let's type in g of x. G of x equals f of x plus 3. So now we're talking about the blue graph. So what I tell students is, because it says what is the range of g of x, we don't want to delete f of x, because if we do, look what happens. All of a sudden we don't have a g of x. So we don't want to delete f of x. What we want to do is hide it. So I'm going to click this red button right here, and that lets me still have it in the calculator, but not on my screen. So let's talk about what domain and range means. Domain stands for all of our input or possible x values. And if it's a continuous graph, so I'm not talking things like exponentials that have asymptotes or inverse functions. If it's your standard quadratic or linear equation, your domain is going to be all real numbers. Basically meaning that x, no matter what, you can put an x number in that's a million and still get an answer. Okay? What is tricky is what comes out, our range. And it's really easy to figure out range when we have quadratics, which this is because it's got a square term in it. And so we're going to zoom back in. And the way that we find the range for quadratics is we find the turning point. In this case, our turning point or our vertex is a minimum. So the lowest possible y value is 2.75. And so the range is all the numbers above y equals above 2.75. But now that I've taught you domain and range so you understand the theory behind it, let me show you what Desmos can do. We can't type in all real numbers necessarily. Okay. We can. No, we're not even going to bother. Okay. So we're going to see if the other three work. And if the other three don't match, like if one of them works, that's the answer. It's going to be letter B. But if it doesn't work, then we can say it's all real numbers. And what I mean by that is we're going to start at the D. I'm going to put y is greater than or equal to 8.75. Well, if we look at that, we can see that that kind of cuts a parabola. Like there's all those numbers underneath that aren't in the green area. So it's not letter D. So now we're going to do letter C. All right, look at letter C. The green part is where there's nothing. The only thing that's in common is where the vertex is in the minimum. So it can't be letter C. Let's look at letter B, which is the correct answer. Whoops. La, aren't you very excited? Look at this. No matter how much I scroll out, the parabola fits perfectly inside the green area, which means that letter B is the correct answer. If it didn't, let's say it was this. This is just to teach you. Do you notice how there's some green parts where there's not the blue graph? Like, do you notice that? Like, do you notice how like right here, there's green that the blue doesn't touch? that would be wrong. Okay, so the one that is the correct touches the minimum or touches the vertex. In this case, it's the minimum and has all the values going up. Okay, now let's just stop there. All right, I love you. Goodbye. See you guys later. Bye.